And now I'm going to start sharing. All right, then. So let me just mention here really quickly before we get going on this example here, that this is our last week. Yay! So I'm going to try very hard to cover 2 chapters today. We'll see. If we don't get to it, it's not the end of the world. But my goal is today we're going to cover chapters 25 and chapter 6. Those used to be in the old book. Those were in the same book, and I don't know why they split them up so drastically, but they did. So anyway, they're really quite related to each other. But we're going to cover chapter 25 first, and hopefully chapter 6. If we don't, we'll cover chapter 6. It's pretty short next time. But my goal is chapter 25 and 6 today. So there'll be a quiz on both chapters and homework on both chapters. That'll be due Wednesday. And then Wednesday, I want to spend the entire time doing a review. So I think I've posted most of the reviews except for this. And then Friday, I'm just going to open up the test. So if we do the review on Wednesday, we won't meet Friday. I'll just open the test at 8 a.m. like normal, and you'll have 2 hours to take it. So it'll be basically kind of like the last test as far as difficulty is concerned. So we'll have we'll definitely cover the chi-square test on it. Plus whatever other hypothesis tests and confidence intervals I feel like. So anyway, that's kind of the goal for this week. So all right, so here's an example I want to go over. A university offers 2 degree programs, electrical engineering and English. Admission is competitive and women expect discrimination. As seen in the table, it's not really below, to the side, 57% of the applicants are men. Is it fair to conclude discrimination? So, what do you guys think? What would be some good calculations you could do to see if there's some discrimination going on?
Well, the proportion of like males and females that are like entering is different because like 80 males are applying and like only 60 females are applying. So I guess you try and figure out the proportion like of the acceptance versus how many people are applying and then like compare those two.
Okay, so we could get the admit percent. And how would I do that? That was a good start there, Allie.
You just take the 35 divided by 80, and then for the female, the 20 divided by 60.
Okay, so I'll copy that formula. So we've got 43% of men are admitted, but just 33% of women. So what do you think, Allie?
Well, statistically there is a difference, so there might be discrimination, but I'm guessing there's something else that can make that more accurate. I just don't know what it is yet.
Wow, very astute. Okay. So do you guys agree with her? Sure, here, we're going to do a poll. Do you agree with
Always with the polls.
I know. We got to get some class participation here. And I didn't poll on you last week, so I got to make up for it this week. So who agrees with Allie and who disagrees? Five, six. We got 7 people here today. Oh, we got to disagree. Janie disagrees. 2, 3. Oh, Janie, did you take away your disagreement? Did you just click the wrong one, Janie?
Yes, I did.
Darn, I was going to ask you why. All right.
No, I'm not playing that way.
You're going with the crowd. All right. What if the crowd's wrong? So, Bridger, I always wonder if you're never listening, but this is our first poll right off the bat, and apparently you're not listening because you're not voting in the poll. So, do you just walk away or what? Anyway, okay, so that was very good, Ali. So this is way too easy of a calculation for us to be doing this. So so yes, we've got to come up with something a little differently. So today's lecture is going to be, what we're going to do is, as you all know, the chi-square test of independence. Okay. Now, the Greek letter chi, I probably should show you here. Chi-square independence. Hopefully Google will tell me. Oh, didn't do that. I thought it would do it right off the bat. The Greek letter chi, oh, come on. It looks like a script X. Oh, come on. Greek letter chi. Okay, so you can see this here. It looks like a script X. I guess so the uppercase X, it is an X, but the lowercase is kind of a, anyway, slightly different. So so that's the Greek letter. So I always like to joke with people that it's Greek, it's not Chinese, chi-square. If anybody calls it chi-square, you lose a point on your quiz next time, okay? Anyway, it's a chi-square test of independence, okay? So a lot of times we'll just use the letter X. So it kind of looks like X squared in a way, but it's actually called the chi. So this one is a little bit different. Okay, now so let me just throw this out at you. Well, I already picked on Allie. So how about, or Allie volunteered, so I won't pick on her again. But Janie, let's pick on you since you're a woman and since this is about discrimination here against women. What do you think? So we're going to do a hypothesis test on here. And based on 43 versus 33, what do you think is going to happen? Are we going to conclude discrimination, or do you think there's not enough evidence for discrimination? I'm just curious. And I know this is a total guess, and it's fine if you're not right, but I'm just curious what you think.
I'm just gonna say because maybe the percentage is higher, there will be a little discrimination.
Okay. Anybody else? Let's pick on a man this time. Let's pick on Easton. What do you think?
Yes, I think there's discrimination.
You think there's discrimination? All right. Okay. I won't make you vote on that. All right. So whenever we do a hypothesis test, what is the first thing that we're supposed to do?
List the numbers.
Find the numbers. Okay. All right. So in this case, the numbers are already here. We do have a total for here. We do not have a total for the rows though, but so that's something else you're going to need to do. So we've got column totals. Let's go ahead and get the row totals as well. Okay. Now, one of the nice things about, and actually I need the grand total as well. Oh, and by the way, I should mention that. Here, let me do this again. Well, you guys won't be using Excel. I still want to mention this again. Because I guess you'll be using your calculators. Well, I guess it doesn't matter. Excel actually is a lot easier to do this on, but I just do want to mention this really quickly. If you want to practice on your, I don't know, it'll make any difference because you'll be doing it on your calculator. You probably shouldn't matter. But the one thing I do want to mention is if you press that sum totals, notice it adds up the row and the row. And then if you press it a third time, it adds up the column, which in this case is okay. But if you have more than 2 rows of data, and there are cases that you will, that can be a cause of a mistake, because you want to make sure you're adding up the row, not the column. But anyway, all right, so that's part of your find the numbers. Now, the other thing with the chi-square test is you have degrees of freedom, okay? But in the past, we've always said degrees of freedom was n minus 1. But in this case, it's your number of rows minus 1 times your number of columns minus 1. Okay, so this is a different degrees of freedom. Okay, now we're not going to count the totals in here. So I'm here, let me do it this way. I'll highlight that. So how many rows do I have?
2.
Okay, so 2 minus 1 is 1. I've got 2 columns, right? 2 minus 1 is 1. So 1 times 1, in this case, equals 1. So it's not 139. Okay, I just want to make sure we're clear on that. Okay, so we will need to use that information later. But when you're doing your chi-square test of independence, it's number of rows minus 1 times number of columns minus 1. Okay. All right, so step number 2 is what?
Decide if it's categorical or quantitative.
Categorical or quantitative. Well done, Easton. And what do you think?
Categorical.
Categorical, that's for sure. Okay. All right, step number 3 is somebody besides Easton. Must be Seth's turn.
Find the null and the alternative hypothesis.
The null and the alternative hypothesis. Okay. Now, I'm going to give these to you because this one breaks the rule that we had last week. Okay. Now, the short answer is you can, so here I'll just put, so this one you can use a sentence for this one. Okay. Now, the short thing is we're going to say independence and not independence. But however, if you put independence and not independence, you will only get partial credit because you need to put the variables. So the variables in this case would be admit rate is independent of gender. Okay. Now, and then admit rate is not independent of gender. Now, a couple things. You may be tempted to say, well, the opposite of independence is dependence, but we're talking about a school, okay? So never put dependent as your alternative hypothesis. The idea here is we're trying to include, is it fair to include discrimination against women? And so our initial indication is, hey, there might be some discrimination going on. But it's not as if there's some biological reason why women are being discriminated against. There's probably some lurking variable that we're not considering, or if there is something going on here. Even if we conclude that there's discrimination or that the admit rate for men is higher than women, it doesn't mean that there's some like biological reason for that. Okay, and so this is one of those weird things where we don't say dependent, we say not independent, because, and the reason why is just, number one, statisticians are a little bit anal, and that we just do that, okay? All right, so any questions on step number 3? Okay, I'll take that as a no. Step number 4 is what?
Pick a test.
Pick the test.
And in this case, it'd be the chi-square test.
Oh, you said it wrong.
Oh, I'm sorry.
I gotta take off a point off your quiz next time. Okay. All right, so pick the test, and it is going to be the chi-square test. And chi-square test of independence. Now, there is more than one chi-square test. Technically, ours is going to be chi-square test of independence. And that's what we're going to use. I think in the book, it also refers it as the homogeneity of proportions. You can just call it the chi-square independence test. I'm not going to make a difference about that. But we're just saying that these proportions are homogeneous, okay? Now, they don't look like they are, but that's just another way to say it. So don't get confused if it asks for the homogeneity of proportions. It's basically asking the same sort of a thing. Okay, so now I've got to give you the equations for that. Now, let me pull up. There's 2 sets of equations that we're going to need, okay? And I'm going to go up here. So 4 continued. Okay, and in fact, let me do this. I'm going to call this the observed table, okay? Normally when I'm teaching my classes, we usually do this in Excel. And I always tell people to make 2 copies of the table. So you're essentially going to make 2 copies of the table. And I don't need the totals in there. I just need the data. So this is what we're going to call the expected table. And then the third table we're going to call is the observed minus the expected table. Okay. Now, let me show you the formula sheet. Never mind. No, I had it open here. No, I didn't. Okay, there's actually 2 sets of formulas that you're going to need to know for this test, okay? Now, I'm glad I brought this up, okay? So as we're looking at this, I've given an example of a 3x3 table on the formula sheet. So this is going to be row 1, column 1, row 1, column 2, row 1, column 3, row 2, column 1, row 2, column 2, row 2, column 3, row 3, column 1, row 3, column 2, and row 3, column 2. Column 3, I mean. Okay, so these are the 2 formulas that you're going to need. You're going to need the chi-squared test statistic, which is right here. And you're also going to need your expected count table. Now, the expected count, this formula changes depending on where you are, okay? I'm going to copy both of these here really quickly. And I'm going to paste it here. Maybe I'll just do it this way. So that we have them here. Okay. All right. So let's talk about the expected counts. So that's the bottom equation here. Okay. Now currently I'm in row 1, column 1. Okay. And so in this case, what I'm going to do is I'm going to take the row 1 total times the column 1 total. I'm going to divide it by the grand total, 140 students. Okay. And I'm going to press enter. Okay. So basically, here's what this means. Under the null hypothesis, we are saying that the admission rate is independent of gender. So if it were independent of gender, if there was no difference between gender, we would have expected 31.5 males to be admitted. Obviously, we can't admit half a male, but anyway, we admitted 35 males. So we should have only admitted 31. So the question is 35 close to 31.5, or is it too far away? We'll talk about that in a minute. Okay. Now, in the table, I'm in row 2, column 1. Okay. So in this case, I'm going to modify this equation slightly because I'm in row 2 total times column 1 total divided by the grand total. Okay. So now, if it were independent, I would have denied 48.5 males from admission. I only denied 45. Okay. Now we're going to do the same thing for the females. Now, where am I at on my table? I'm in row 1, column 2. Okay. So I'm going to take the row 1 total times the column 2 total divided by the grand total. Okay. I'm going to do that one more time. Row 2 times column 2 divided by the grand total. Okay. All right, so that is my expected table. So I've done this bottom formula, okay? Now, what I need to do is find out the chi-square sum. Okay, that's the other formula here. Now, so this is very important that you're going to take your, use parentheses on this one, okay? So I'm going to take the observed. I observed that 35 males were admitted. I'm going to subtract the 31.5 who were expected. I'm going to close my parenthesis. I'm going to square that. And I'm going to divide by the expected count of 31.5 males. Okay. I'm going to do the same thing here. Okay. I'm going to take the observed. I observed 45 were denied. I'm going to subtract off the 48.5 that were expected. I'm going to square that, and I'm going to divide it by the expected. Okay. Once again, I'm going to do the same thing. I observed that 20 females were admitted. I'm going to subtract the 23.5 who were expected. I'm going to square it. I'm going to divide by the 23.5 again. Okay, the expected. And finally, I'm going to take the observed 40 minus the expected 36.5. I'm going to square the difference, and I'm going to divide by the 36.5. Okay. All right. Now, remind me again, who haven't I picked on today? Who's here? Elise, it must be your turn. Elise, remind me again, what does this symbol mean here? It looks like an E kind of a thing.
Sum. It means sum.
It means the sum. Very good. Okay. So what we're going to do is we're going to take the sum of this entire table here. Okay, and I'm going to hit the total here. I'm going to add up this entire table, and I got a sum of 1.5597. Okay. Now, one other thing that I forgot to mention. Okay. So you can think of this when we're talking about admit rate is independent of gender. Normally we would put an equal sign here, right? And I wouldn't allow you to put a times there. But we would say, essentially what we're saying is admit rate for the men is equal to the admit rate for the women, okay? And with the admit rate is not independent, this is always going to be a greater than or a right-tailed. Okay. You can think of it this way. So so normally, well, with the chi-square independence test, your alternative test is always right-tailed. Okay. Now, let me just show you something really quickly here before we get going too far here. Okay. Test of or actually I want the distribution. Okay, so this is a great little chart here. Now, the one thing that I just want to emphasize here is that probably should talk a little bit about the chi-square test. So the thing that I want to emphasize here, let me see if maybe I should go over my notes here. Let me catch up to my notes here. Okay, so I've got a lot of this here, and I will definitely post this stuff. The null hypothesis, in my notes I said there's no difference between the males and the female admit rate. I probably should say that. Although the alternative is saying there is a difference, okay? All right, so I've got all this stuff here. Okay, oh, I didn't put that in there. Okay, I need to add on here something. So chi-square test of independence. We talked about your degrees of freedom. Okay, rows -1 times your columns -1. I should also mention that the shape of the distribution changes based on degrees of freedom, and it is not symmetric. When I say it's not symmetric, I mean it's not symmetric. Okay, now, for some reason, I don't know why, this is a great little chart here, but for some reason, instead of putting DF for degrees of freedom, they put the letter K, which I don't really know why. If your degrees of freedom is 1, it's this yellow line here, which as you can tell is not even close to symmetric. If your degrees of freedom is 2, it's the green line, okay? If your degrees of freedom is 3, it's this light blue line. So instead of starting at the top, it now starts at the bottom. 4 is your dark blue line. 6 is your purple line. 9 is your red line, okay? So you can see, especially when your degrees of freedom is very small, you've got some real changes. Now, let me also mention the chi-square table, okay? All right, so with your sheet, we've got a chi-square table, okay? So this is your chi-square table. Now for us, we're lucky in the fact that we are always going to be doing a right-tailed test, okay? Now, just for fun, let me go back to here. Now, let's pretend for a moment that the observed and the expected were the same. So I'm going to change these values. Let's pretend that this was 35 and 45 and 20 and 40, okay? So you can see that there's no difference between the expected table and our observed table. And you can see that these numbers are all close to 0. And so, one other thing I forgot to mention about this thing. It's not symmetric, it's always positive because we're squaring. Essentially what we're doing is we're squaring everything. So the 0, so this value here is always going to be 0, and if we're doing this, if we're doing a chi-square distribution, I'm going to change this back to where it was. Okay. then if we're doing a right tail test, then our sum will be large. So one way to think about this is we're going to reject the null if the sum is large. Okay? Now the question is, what is large? And so that's where the chi-square test comes in, okay? So essentially, so you can kind of ignore these other two numbers. If you take my math 2040 test, we'll do some left tail tests and some two tails tests. But in our class, we're only going to be doing a right tail test, okay? So that kind of makes it kind of nice, okay? Now, our degrees of freedom, once again, is 1 degree of freedom. So we're going to be looking at the top line, okay? So this tells you the area to the right. So like the normal distribution tells you the area to the, the normal distribution tells you the area to the left. T-distribution tells you the area to the right. The chi-square distribution also tells you the area to the right, okay? Now what we're looking for is we're looking for our sum, 1.55. We're looking for that on this first row. So where does 1.55 fit?
In between 0.016 and 2.706?
Yes, that's correct. So it's in between these two numbers here, which means it's going to be in between those two numbers there. Okay. So essentially, let me back. I guess I need to keep going. Okay. So the chi-square test statistic, I'll put this in blue. So when we're doing this on the test or on the, well, I gotta figure out what I'm doing on the quiz. But if I ask you on test number 4, pick the chi-square test, or pick the test, you're going to tell me it's the chi-square test of independence, and the test statistic in this case is 1.55. Step number 5 is what?
Find the p-value.
Find the p-value. Thank you, Elise. Okay. So the p-value, we're going to look at the chart, and so we're going to say that the p-value is in between 0.10 and 0.90. Okay. So 0.10 is less than p-value, which is less than 0.90. Okay. By the way, I forgot to mention, what's our alpha in this case?
0.05.
0.05. Okay. So step number 6 is what? What I picked on. How about Wes? I haven't heard from Wes today, have I? Is Wes here?
Yeah, I'm here.
Okay, you're not on camera today.
Yeah, I'm still in my pajamas.
Yeah.
We're gonna go ahead and compare the p-value to the alpha.
Compare to the alpha. In this case, what are you going to do? We're going to reject or not.
And we're not going to reject this time.
Not reject. Okay. So we're not rejecting the null hypothesis, which means what is our conclusion?
That there definitely seems to be some gender discrimination.
Okay, so let's think about this. We said we're not rejecting the null. Okay. So the null says if we follow our null hypothesis, then here, let me do it this way. The admit rate is or is not, I'll let you pick, is not independent of gender.
The admit rate is not independent of gender.
Okay, so you're saying there is discrimination.
Correct. Oh,
okay.
No, we.
So you said.
Never mind. If we did not reject the null, then the admittance rate is independent of gender. Oh man, now I've talked myself into confusion again.
Yeah, you're confusing me too. Here, should we do a vote here? So in this case, independent means no discrimination, and not independent means there is discrimination. Vote. Oh, we've got 6 people voting now. So you're all saying it's independent? Okay, so we've changed our mind here. It is independent, and there is not evidence of discrimination. And it seems like we all agree with that. Okay? So that is the correct answer. But Ali, I have a question for you. There's a 10% difference in admit rate. How can we say that there's no discrimination going on?
Well, when we do the
That seems like a big gap, doesn't it?
it's because we're comparing the alphas, right? That's how we like if it's within that close
We're
to the
comparing our p-value to our alpha, yes.
yeah. And because the p-value is like I guess comparable to the alpha because like because the p-value is greater than the alpha, then that's like what's causing us to reject or deny it.
Well, so you're explaining the statistics here, but I want you to put your woman hat on for a minute. Okay. You're the protesting woman, and you say, "Look at this. Women clearly are being discriminated against. I don't trust statistics. I think it's all a bunch of gobbledygook, and plus I don't understand it very well." How can we say that a 10% difference is not a big difference? Aren't you thinking that as a woman, not as a mathematician?
Well, personally, I don't really care about those type of things, but
All right.
I guess.
Okay, so I'm going to give all the men A's and all the women C's, right? Because you don't care.
Okay, well now I care. But I don't know. I don't know exactly what's making that big difference between the 10%. Like is the 10% like within margin of error or something, or I don't know.
Let's think about what could be going on here, right? So can you guys think of anything that might be going on here? Why is this 10% not a significant difference? And let me tell you something. Although this is fake data, it was based on a true story. Okay. There was a lawsuit filed at the University of California at Berkeley, and one of the things that they found was it looked like just like this: women were being discriminated against. And then they did a bunch of test statistics, and they says, no, there's no discrimination. And they said, there's got to be discrimination. Okay. So let me just tell you really quickly. I'm actually kind of excited. I've technically finished chapter 25, which is the chi-square test of independence that I clearly can't spell very well. And now we're going to get into chapter 6. Which is called Simpsons Paradox. Okay. And I'm sure you guys are going to want these things here. Okay, so they said, okay, fine. Let's go back here. So the university offers 2-degree programs, engineering and English. Okay, so they said, okay, well, maybe if we look at just one department, let's look at the engineering department. We want you to tell us your admit rate. And we're going to do it not only for the engineering department, we're going to do it for the English department. Okay. So maybe it's just one department that's discriminating. So they said, can you please tell us your numbers? And so the engineering department said, okay, fine. We had 30 males admitted, and we had 30 females, or 30 males denied. And I bet you guys can figure out your admit percentage on that one without thinking too hard. What's the admission percentage for the males?
50%.
It's 50%. Okay. We had 10 females admitted. We had 10 females who were denied. What is your admission percentage on this one?
%50.
50%. So I think it's pretty safe to say there's no discrimination in the engineering department. Okay. Can you see that? All right, so let's go to the English department. In the English department, they say, okay, give us your numbers. There were 5 men admitted. There were 15 denied. This one might be a little bit harder, but can you figure out your admit percentage on this one?
33.
No, it's only 25%. 5 out of 20. Does that make sense?
Yep,
Okay.
yep.
And with the women, there were 10 admitted. There were 30 denied, which also gives us an admit rate of
25%.
25%. So there was no discrimination in the English department. Okay. Now, if you add these up and you put them back in here into the total tables, in fact, I think I did this right. So 30 plus 5 is 35, and 10 plus 10 is 20. Okay, so these numbers match. Okay, so the problem is, okay, this is a case of what we call Simpsons Paradox. Okay, Simpsons Paradox states that if the sizes of the groups different, associations can actually reverse. Now here's actually what happened at, I'm going to try to make this work, okay? And in fact, this is what happened at Cal Berkeley. Now, the way we did this, I purposely did this so that these were exactly, the admit rates aren't the same, but they are equal between men and women, okay? In the case at Cal Berkeley, one of the things that they found was, let's change this to 29, let's change this to 31, okay? So now, 29 divided by 60 works out to be 48%. Now, in this case, it looks like the men are being discriminated against. And let's change this to 4 and 16. 4 divided by 20. Now it looks like in both cases, the men are being discriminated against, okay? Whereas when you combine them, it looks like the men are getting the better deal, okay? So this is another case of Simpsons Paradox. If your groups are different, now notice as we look at this, okay, when we look at the engineering department, you've got 80 people. And when we look at the English department, you've only got 60 people. Okay, so the problem is because you've got so many more people in the engineering department than the English department, the engineering department overwhelms the English department. And so when you combine them into here, it looks like the males have it better. The women are being discriminated against. But in fact, the reality was, and this is what happened at Cal Berkeley, they went back to, there were actually 6 colleges, not just 2. They found that the women were being given an advantage in the engineering department. And in fact, the interesting thing was, like in the health sciences department, there's a lot more nursing students that are women. And so because they had tried to increase the number of men, so in every department there was a kind of reverse discrimination going on because they were trying to have more men in the health department and more women in the science departments. And so in every case, the underrepresented group had a better admission rate than the other groups. So so this is a case of what we would call Simpsons Paradox. And so the problem is when you combine everything into one table, it looks like it's discrimination against women, when in fact it was discrimination against men. So that's an example of Simpsons Paradox. So, any questions on that? All right. Well, gosh, I'm done with this way earlier than I expected. I thought it would take more time. We'll do another example because I know these are hard, but I covered that whole thing really much faster than I expected. So let's go ahead. Let me think if I can do another one. Wonder if I have some examples. Let me check here. Oh, this is a good one. I wonder if I can copy this to Excel. Okay, so I'd like to do another one because I want to make sure you guys are going to ace my quiz on Wednesday and test on Friday. All right, move this down a little bit. General surveys, social survey asked adults their opinion about astrology. They wondered if education affected opinion. Here. Okay, general social survey asked a random sample of adults their opinion about astrology. They wondered if education level affected their opinion as to whether astrology is scientific. Data are given below. Use alpha equal 0.05. Okay. Now, I guess one of the lucky things about the chi-square test of independence is it's always going to be in the table. So that's usually a dead giveaway. So anyway, let's go ahead and go through all the numbers. So whose turn is it? Easton, why don't you start us off? How do we, how should we start off this? And Easton, if you're talking, we can't hear you.
Sorry. So we need to find the numbers.
Yep, find the numbers.
And so we need to get the totals for the different columns and the different rows.
So we need the totals for the columns and the rows. Okay. The nice thing about Excel is you can do this faster. Okay.
And then would
All
we
right.
also want to write down that alpha is equal to 0.5?
Alpha equals 0.05. And is there anything else?
Not that I can see.
Yeah, probably degrees of freedom. What's your degrees of freedom?
So isn't it going to be 1 times 2?
So I'm the one asking the questions here.
I'm pretty certain it's supposed to be, because like
You're
you
pretty
take the
certain
number.
it's 1 times 2?
Yes.
1 times 2, which equals 2. And how did you get that?
Because you take the number of rows,
We've got
minus
2
one.
rows. Minus 1 is 1.
and then you take the number of columns,
3
minus 1.
columns, minus 1 is 2. Perfect. Okay, well done. All right, step number 2 is what? Janie, it must be your turn.
We decide if it's quantitative or categorical.
Quantitative or categorical. And what do you think?
Categorical.
You know what the categories are?
Junior college, bachelor, and graduate, right?
Actually scientific and not scientific,
Oh,
but yeah.
that makes sense. Yeah.
Okay. All right, step number 3 is what, Wes?
We're going to write our null and our alternative hypotenuse.
Hypotenuse?
Or sorry,
Hypothesis.
hypothesis. Sorry.
That's okay. All right, what do we got for the null?
It's they want to know if the education level affected the opinions of whether astrology is scientific. So I guess the null would be education level does not affect the opinion of whether astrology is scientific.
Okay, and so
Or it
rather than,
does. I'm not really sure in this case what the null would be versus these.
so the 2 variables are education level and opinion. We'll just call it that way.
Yeah.
Okay, now the question is, this is a chi-square test of independent. Well, I guess that's step number 4, right? Test is high. Yeah. So I need independence or not independence. So is that the null? Which one says that it doesn't matter?
The alternative says it doesn't matter. Or no, the null.
The null says it doesn't matter. So education level and opinion are
Independent.
independent. Okay. And then the alternative is
Education and level and opinion are not independent.
okay. Well done. Okay, does that make sense? So So another way to think of this is education level does not affect opinion, whereas education level does affect opinion. So that's another way to think about it. But as far as the right answer here, I want to have independent on the first one, and I want to have not independent on the second one. Does that make sense? All right, step number 4 is what? Whose turn is it now? Allie, it must be your turn.
So the next step is to decide what test we're doing.
Okay.
And I don't know, I'm gonna say it wrong again. We're doing the chai test.
With Greek
Uh,
test. I was trying to give you a reprieve here.
I'm
2
sorry.
points off on your next quiz. Chi test of independence. Okay. All right. So we're going to call this our observed. Now we've got 6 spots here. So you're all going to get an opportunity to help me figure out how to do this. This is going to be my expected table. And this is going to be my observed minus the expected table. Okay? All right, so Allie, we'll let you be the first one. Do you know how to fill out this table? Here, let me copy. I'm going to copy this thing over here so you can look at it. I'm going to make it a little bit smaller though.
So the first one for like the non-scientific junior college, you're gonna take the total divided by like, so
So pick numbers.
trying to remember. It was you
Okay,
take
so
the one.
before you start guessing here, let me just remind you. Okay, where am I on my table right now?
You're in the row 1, column 1.
Exactly. I'm in row 1, column 1. So what am I grabbing here?
You'll grab the row 1
Total, which
total.
is?
Uh-huh.
What value is the total of row 1?
396.
396.
And then I know you also grabbed the total of the column 1. I
Okay.
don't remember what you do with it.
So you got your formula right here.
Okay. So you multiply it by the column 1.
So, and don't forget your parentheses. By the way, that's the biggest mistake that people do is they forget their parentheses. They use all the correct numbers, but because they don't use parentheses, they get it wrong. So the column 1 total is what value?
130.
130.
And then you divide all of that by the grand total, which is 524.
You got to do something before you divide it.
Well, you multiply the two, like the two totals, right? And then you divide
never
it.
mind. Divide it by the grand total. I was getting my own formulas mixed up. Okay.
Oh, okay.
Sorry. Okay. So this one, I said you don't need parentheses on this one. I forgot. Okay. All right. So well done, Allie. Next person up is Seth. You get to tell me the next value here. We're all going to take a turn since there's 6 of us left. So where am I on the table?
Scientific row. Wait, yeah, row 2, column 1, and
Okay,
then
row. So
it's
row 2
40.
total is
128,
128
and then row 1 is 130.
times 130.
Yeah, column 1.
Okay. And then
Multiplying, right?
so I'm
Divide
going to multiply those and divide by,
the grand total,
which is
524.
524. Okay. Well done. Now we're on, that was Seth. Elise, what do we do next? Elise, if you can hear us, you must be on mute because we don't hear you. At least step away. Okay, Easton, take it away. Where are we at?
So we are in row 1, column 2.
Okay.
So it would be the row 1 total, which is 396,
396.
times the column 2 total, which is 255, divided by the grand total of 524.
24. Okay. Now it's Janie's turn.
So we do the 396.
Where am I? Where am I on my table?
Oh, we're in row 2, column 2.
That's correct.
So we do the 396.
Nope. That's in
No?
row 1.
Oh, 128
128.
times 255
Mm-hmm.
divided by 524.
Okay. Now it's Wes's turn.
So we're in row 3, column 1.
Okay.
Or sorry, row 1, column 3. Sorry. Damn that dyslexia. So we're gonna go 396 times 139 divided by 524.
Okay. Hopefully Elise is back. Are you back, Elise? Can you hear me? Elise must have walked away or something. Janie, do you want to do it again just for fun?
Sure. So we're in column 2, row 3.
Okay.
And then we do 128 times 139 divided by 524.
Okay. All right. So we're halfway through step number 4. Now we get to do well, not really the same thing, but something similar with the third table here. So, whose turn is it again? Allie, it must be your turn.
Okay. So I'm actually kind of, is this when you do the sums or when?
We'll do the sum at the end, but yeah, it's this equation right here that we're using.
Okay, so the observed is the 87.
And this is where the parentheses really, really, really matter. Okay.
And then
So 87.
And the expected. Well, what do you find the expected? Is that like based off of the null hypothesis, or is that just a number that I'm overlooking?
So this is your expected table here, this second table.
Oh, that okay, yeah.
Now that second
So-
table does represent the null hypothesis. That's correct.
Okay, so that would be minus, or you'd subtract the 98.24427.
Okay.
And then, so do you square that now?
Yeah, you need to close your parenthesis and then square it now.
You square it and then you divide it by, would it be like the sum of the expected?
No, it's just that same number again, 98.
Oh,
So you can use that 98 twice.
okay.
Okay. All right. So now, whose turn is it? Now it is Seth's turn.
All right, then you go 40 Yeah, 43 minus 31.75573. And then you square, you square it. And then divide by 31. Yeah,
Okay.
each 7, yeah.
Well done. All right, so now whose turn is it? It is Janie's turn, I think.
So for this one, we do 396.
Nope, we're not dealing with totals anymore.
Wait, then I don't understand what we're doing.
Okay, so the
Oh, we're doing
observed,
that
we're looking at
one?
the observed table. Yeah, we're doing this one.
Okay. So we do 198
Okay,
minus 192.7099 divided by,
nope, we're not dividing yet. You gotta finish.
oh, squared it. We square it.
Square the numerator.
And then we divide it by the 255, no, the 524.
Nope, the note 192 again.
Oh, okay.
You're gonna use that same number twice. Okay. All right. Now, whose turn is it? It must be Wes's turn.
All right, and in this case, we're gonna go the 57 minus the 62.29008 and square that and divide it by that same cell.
Okay. Elise, are you here? Elise walked away.
Yes.
Oh, you are here.
Yeah. I was just outside. My roommate was calling me.
Okay. What do we do here?
So is that 111 minus 105.0458,
Mm-hmm.
and we squared it,
Mm-hmm.
divided by 105.0458.
Okay. Trying to remember who I didn't pick on. I think it was Easton. I haven't picked on Easton, have I? For this table?
have.
Oh, I have? Who did I miss?
No, you haven't. It's
Oh, I haven't. Okay, thank you.
So this one is going to be 28 minus 333.9542.
33.
33, sorry. You square that, and then you're going to divide it by the 33.95.
Okay. All right, Allie, I think it's your turn again. What do I do next?
So that's, now you find the sum of all of them.
Okay. So it's the sum of this entire table, right?
Mm-hmm.
So the sum of this table right here. Okay, and the sum is 7.244. Okay, step number 5 is what? Seth.
You find the p-value.
Boy, Seth, your voice got really high there.
Oh, wait, sorry, I didn't hear that you asked that.
That's what Seth was going to say, right?
Yep, sorry. Took me a second.
Yeah, no problem. So do you know how to find the p-value?
You go to the table and
Table. So remind me, how many degrees of freedom I have?
You have 5.
Nope.
I thought it was the rows. Okay. 2.
2. So do you remember how to calculate that again?
It was the number of rows and the number of columns. Let me think.
So we got 2 rows, right?
Yeah.
2
Okay.
rows minus 1 is 1. 3
I was
columns.
the amount of columns and rows, but yeah, it makes more sense.
Okay. All right. So we got 2 degrees of freedom. Okay. So we got 2 degrees of freedom. So we're looking at this line now, right? And what are we looking for?
Are we looking at our sum?
We're looking at our sum. Our sum is the big number. So 7.24, we're looking for on that line.
So it would be 7.24. It would be in between 0.05 and 0.025.
Yeah. So typically when we're doing that, we will write it with the smaller number first. So 0.025 is less than p-value is less than 0.05. Okay. So that's what we'll do there. Step number 6 is what, Janie?
We compare it to the alpha.
To the alpha. Step number 7 says, I'll let you go again, Janie. Because 6 is just like.
Yeah. This isn't where we write the conclusion, is it?
No. It's the step before that.
Oh, to reject or not reject it.
Reject or not? What do you think?
I'm probably going to get this wrong, but not reject.
Okay. So, do you remember the phrase that pays?
Oh, is it there is significant evidence?
Value is low.
No, I don't remember.
Oh. Who remembers?
If the p-value is low, reject the hoe.
Is my p-value low, Janie?
Yes.
We're comparing this now. Here, I'll put that in a different color. Comparing that to this. So my p-value, is it low?
Yeah.
Yes. So therefore you
reject.
You reject. Okay. So does that make sense now?
Yes.
Are you going to ever forget the phrase that pays again?
No.
All right. I won't keep picking on you unless you want me to. Do you want to do the conclusion or do you want somebody else to do it?
I would like someone else to do it.
Okay. So whose turn is it now? Elise, I think it's your turn. What's the conclusion?
So there is evidence.
I heard you say there's evidence and then something happened to your microphone or something.
Yes, I'm still reading the question.
Okay.
Yeah. So there is evidence that the education level affects the opinion as. Yes, so there is evidence that the education affects people's opinions.
Okay, and that I like that you said that, because that's what a normal person would say. Would you say it's independent or not independent?
It's independent.
No, it's not independent.
Oh, not independent.
Okay, remember we rejected the null. The null said it was independent. So that means we think that the alternative is true. So that means it's not independent. So we think the education level does affect opinions. Okay. All right. Now, who wants extra credit on the quiz and the final?
Ooh, pick me, pick me.
Me
Okay.
too.
So I'm glad we did this problem, because we think the education level affects opinions. Okay. Now that's a true conclusion. Now the obvious next thing says, well, how does the education level affect opinions? Okay. So for extra credit, here's what I want you to do. Okay. So the idea here is we think that this is not independent. Okay. We also know to reject if the sum is large, right? And so in this case, we're rejecting the null. We're saying that this sum is too large. Okay. Now the question is, when we look at this table, which value contributes most to the sum?
Those junior college kids.
Yeah, that's the one right there, right? Okay. So the junior college people think that astrology is scientific. In fact, more junior college students think astrology is scientific. Okay. What's the next biggest number?
Grad students.
It's actually this one here. But we probably don't want to do the junior college again. So yeah, I'd probably go with the graduate students. So fewer grad students think astrology is scientific. Maybe I should say than expected. Let me finish that. We should put that here. Than expected. Okay. So the idea here is if your education level didn't affect your opinion, we would have expected just 31 junior college, and we got 43. So we got way more junior college that said it was scientific than we expected. Then the next biggest number is the non-scientific. So we got fewer. So we would have expected 98. We only got 87. So fewer junior college said it was not scientific than we would have expected. And then the third highest number, so we can pick a different group, the graduate students. Okay, so 28 is what we got. We got 33. So we got more graduate students that said it was scientific than we would. No, we got fewer graduate students than we expected if opinion didn't matter. Okay, so the idea here is you don't have to go through all of them, but you can see here the smallest value here is 0.33. So the 105 is closer to the 111. So that's closer to 0. So anyway, that's your extra credit. Okay, does that make sense? All right, So we're doing pretty good here. Gosh, we're just cruising on time. Now, I think there is a couple of other things that I forgot to mention here. Let me make sure I don't want to forget these. As far as the notes go, this is very important. Okay, we haven't talked about sample sizes. Let me go back to here because this is a much smaller sample size. Okay, 2 rules on sample sizes. No more than 20% of your cells can be less than 5, and all your counts must be, all your expected counts, I should put in here, expected counts must be greater than 1. Okay, let me go back to this one for a moment. Okay, so let's pretend for a moment that I got a 4 here for my expected count, or 4.1, or we'll try to make it a decimal. Is this big enough?
No.
No, because
Your observed minus expected is greater than 1. Is that what you just said earlier?
oh, well, there's 2 rules here.
Oh,
Okay, if I had gotten a 0 here, then that's a problem.
gotcha.
Okay, what if I get a 4.1? Is 4.1 a problem?
Technically, there's only 25% of the cells, so I guess it shouldn't be a problem. Because your rule is 20, right?
20, yes. So yes, this is a problem. Because 1 out of 4 is 25%. 1 out of 4 is less than 5.
Oh, gotcha.
Okay, and so yes, that's a problem. Okay, you shouldn't run the test. I'll probably make you run it anyway and just say, tell me that that's a problem. But yeah, that would be a problem. Now, going back to this one, if I had, this is my smallest one here. Let's say I had 4.1 here. Would that be a problem?
No.
No. Because that's 1 out of 6 cells, which is 16%. Okay. If I had a 0 here, would that be a problem?
Yes.
Yes. Okay. So let me ask you this question. What if I had, here, I'll put these back the way it was. What if I had a 4 here? Would that be a problem?
No.
No, because
That's not the expected table, it's the observed.
it's the observed, okay? Now, what if I had a 0 here?
Also not a problem?
No, that would be still a problem.
Okay.
If, yeah, so you can't have, so zeros, it doesn't matter which table it's in. You don't, you have to have at least a 1 there. Okay. But yeah, normally it's the expected table that matters. So as long as no more than 25%, so zeros, can't have zeros. But as long as, if this is a 4, let's say, that's still not a problem because my expected count is 23 and it's okay. Okay. In this table here, a 4.1 would be a big problem. Sorry, my phone's ringing. Hopefully somebody else can get that. All right. Is there anything else I need to talk about? I can't believe we got through this so early.
So those expectations, It has to be greater than 1 applies to all tables.
All the tables.
Okay, not just the expected.
Well, I will actually, if you, it wouldn't apply to this one. The third
Okay.
table it doesn't apply to, because those can be close to 0, and that's okay.
So it just applies to the expected and the observed.
Correct.
And then the less than 25%, is that just the expected?
That's just the expected table.
Okay.
Okay. So those are, so now, so we've got 3 sample size rules, okay? N greater than 30 if it's continuous, NPQ greater than 10 if it's a proportion, and in the chi-square test, we have the 2 rules about the zeros and less than 5. Okay? So, gosh, this is great. I didn't think we'd get through both of these today. And we've even got 7 minutes to spare. So let me say this, okay? So just as a reminder, this is the last thing we have to learn for this test. So there'll be 2 homework assignments, chapter 25 and chapter 6, that are going to be due on Wednesday. Wednesday will be just a review day. So I've already posted up all the reviews except for this one. I'll post that one as well. So Wednesday is just going to be a question and answer. You guys can ask me anything about any topic in this class, and Friday we will not meet at all. I will just open it up at 8 a.m. You'll have 2 hours, and it's been great having you. So, do you guys have any questions for me?
I'm sure we'll have questions after the homework.
Yeah. I thought I was going to say something. I forgot what I was going to say. Okay. Well, I'll make sure I've got both of those. I don't know if I'll have 1 or 2 quizzes. I'll probably just, I don't know. There might be 2 quizzes since there's 2 chapters, but they'll be fairly short. Oh, I know what it was. I do have this, I've just done problem 1. I have this worksheet with, there's 7 chi-square problems on them. Would you like to do this as well, just for practice? Well, you don't have to turn it in, but I think I've got answers somewhere too. I think the answers are in a spreadsheet. Just know that I'm not requiring you to do this in a spreadsheet. You'll just need to do it on paper. Would you like this extra thing just for review practice?
Yeah, I like reviews.
Okay. So I will post this as a practice. Of course, we've done number 1. So really, you've only got 6 left. But you can do number 1 again if you want.
And you said that there's going to be the answers too, so we like aren't studying wrong or practicing
I'm
wrong.
pretty sure I have the answers. Yeah, I do. The answers will be in a spreadsheet.
All right, sounds good.
Yeah, problem 1, 2, 3, 4. Yeah. So I'll give you these. So I'll post that as well. So just remember, you're going to have to do this all with a calculator. But okay. Any other questions, comments?
Mm-hmm.
Are you excited that you've learned everything you need to learn in this class?
Yes.
Everything else is review from here on. Okay. So review, we'll just meet as long as you guys want to review. So remember to check the old reviews, the old quizzes, the old tests. I will guarantee that there will be a chi-square test on the final. there'll probably be 1 or 2 more hypothesis tests, confidence intervals, and then everything else that we've studied. Alrighty then. Well, I will let you guys go then. So see you all on Wednesday.
Thank you.
Thanks.